Welcome everybody. Welcome to Mr. Yoshii's math videos, and today we're going to be talking about law of sine and cosine application, some word problems. So let's get started. Number 1, Santiago and Leah are standing at the seashore 10 miles apart because they hate each other for some reason. The coastline is a straight line between them. So before I keep reading, let me actually draw that. So here's my coast, and here's Santiago, and here's Leah, and I guess this is the coast, maybe this is the beach over here, and they're right at the water basically. And it says they are 10 miles apart. So let's draw this distance. I don't have a lot of space, but 10 miles. Both can see the same ship in the water. Okay, and so this is the water over here, and it says the angle between the coastline and the line between the ship and Santiago is 35 degrees. So the boat is out here somewhere, maybe over here. It says a ship, but I don't want to use S, so I'm going to just call it boat. And it says that when I'm looking, let me get this ruler. Okay, I got the ruler. So I'm going to connect the S and the boat, and it's saying, right, the angle between the coastline and the line between Santiago and the ship is 35 degrees. And it says something similar about Leah. So it says that the angle between the coastline and the line of sight to the boat is 45 degrees. So that's my diagram. And what else do I know? I don't think, is there anything else? Nope, it just says how far is the ship from Santiago. So I'm going to call this X. Okay, so with that said, I'm looking at this problem, and the first thing I'm thinking is, can I use law of sine? Because law of sine is the easiest compared, well, not easiest, but it's easier compared to law of cosine. If you can use law of sine, use it. So over here, I know 45 and the opposite side is x, so I know these two are connected, and I need to use this x somehow, so I know I need these to be connected. And what else? Law of sine, I need another angle and its opposite side. 35, I'm missing something, so I don't want that one. And the 10, all about the opposite angle, is missing too, so that means I can't use law of sine. I could only have one unknown. So what do? Well, I'm given two angles, so that means I could figure out what this guy is. And what's that guy? That guy is 180 degrees minus the 35 degrees minus the 45 degrees, and I get 100 degrees. So this guy is 100. Now that I know that, now I could use the law of sine. Awesome. So what's law of sine again? Law of sine is A over sine of A is equal to B over sine of B. And A is the side, and this capital A is the angle. So maybe I'll use these two over here. So the side is X, and sine of angle 45 is equal to B over sine of B. So B is the side, so I'm going to put 10 over sine of angle 100 degrees. Now I cross multiply, so in my calculator I'm going to type in 10 times sine of 45, so let me just do that right here. So turn it on. I said on. Oh, there it is. Okay, that's the button. On. And then I'm going to say 10 times sine of 45. Oh, I get 5 root 2. That kind of sucks. That's not what I was looking for, but that's fine. When I cross multiply, I'm going to get x times sine of 100. So I'm going to just write it as x times sine of 100 degrees is equal to maybe 5 root 2. Why not? And then instead of typing in sine of 100, I'm just going to divide by sine of 100. So on my calculator directly, right now I have 5 root 2, and I'm going to divide that by sine of 100. So divide sine by 100 as such. You don't really need to close the parentheses, but you can. And I press enter. And I get the answer x is equal to 7.180, but it says to the nearest tenth of a mile, so I'm going to say 7.2 miles between Santiago and the ship. Excellent. So now let's move on to the next problem, the tunnel problem. So what does this one say? Maybe I'll zoom out a little bit so that I have more space on my page. Alright, that looks better. Okay, what does it say? It says the tunnel, or and this is from a German problem or German book, so that's why it says Stollen. I'm guessing the S, it's next to a consonant, so I think it's Strollen. And don't make fun of me. So the tunnels, Strollen 1 and 2, are connected by a connecting tunnel that leads from point A to point B. Okay, so this is the new tunnel right here. And it says calculate the measures of angle A and B, which is talking about these Greek letters alpha and beta, required to make the connecting tunnel run in a straight line, and how long will the connecting tunnel be. Okay, so I need to figure out how long this is, so I'm going to put x here, and you probably could barely see it because it's a pencil and behind a gray background. But anyway, so looking at this, I can't directly find alpha and beta using the fact that 180 when you add the three angles, so that doesn't help. And can I use law of sine? Well, this 46 degrees is connected with x. I don't know that. And unfortunately, the 250 is connected with something I don't know, and 300 is connected with something I don't know. So that's two unknowns if I try to use law of sine. No good. So what's my last option? Law of cosine, which you can use because I have an angle with two sides next to it. Alright, so that is the classic law of cosine, right? Side, angle, side. So I'm going to use the formula C is equal to a squared plus b squared minus 2ab times cosine of C. Okay, and so what are these things? C is the one that's lonely here, and AB is these guys on the sides next to the 46. Alright, so this is my, I can't even see again, A, and that's supposed to be my B, and this X is supposed to be my C. Okay, so with that said, I'm going to plug everything in, so I get X squared is equal to A is 250 squared plus 300 squared minus 250, 300 cosine of 46 degrees. Woo! Just writing all that is tiresome. And what I'm going to do is, bam, just put all this in the calculator all at once, just being very, very careful. So I'm going to write 250 square plus 300 square minus 2 times 250 times 300, and then times cosine of 46. And what do I get? This huge number. So I get x squared is equal to 48301.2444. Okay, and then it says to take the square root. So I'm going to take the square root, and I'm going to put plus and minus, even though I know I don't need the negative, but I just want you to get used to putting plus and minus, because that's what happens anytime you take the square root. And so I get x is equal to plus and minus square root this number. And so I'm going to do that in the calculator. So I'm going to say square root of that answer I just had. Boom! And I get x is equal to positive 219.775. And it says, well, actually it doesn't say where to round, but as you can see from the problem, this tunnel's 250, 300. The actual measurement might be 250.12 or 300.6, but or it shouldn't be 6, but 300.4 or something like that. But it doesn't say, so I'm going to do the same. I'm going to say the tunnel is about 220 meters long. Woohoo! Now that I got that, can I find alpha and beta? Of course I can. And let me move my camera a little bit so I can get to the bottom part. Okay, so can I figure out the angle? Of course I can, because now I have this side. As you recall in the beginning when I was talking about law of sine, I said, okay, law of sine requires these two sides, and maybe I could use these two sides. Now that I have x, these are both known, and now I only have one unknown, which is alpha. So now I could use law of sine, so I'm going to use a over sine of a is equal to b over sine of b. Okay, with that said, okay, what was a? Okay, let's go back to here. Okay, a is the side, so it was x. Now don't use 220, right? I want to use exact values, right? I don't want to use rounded values in my question until the very end. So even in this problem, I'm going to use 219.775 over sine of that angle across or opposite. And for the b, what do I want? For the b, not the beta, the b is actually, oh, that's a little confusing. But over here is the other pair. So in this case, the side b is 300 over sine of alpha. Okay, so now I just have to solve that equation. So I'm going to cross multiply again, and I'm going to first maybe cross multiply this and write 219.775 of sine alpha is equal to, and I'm going to type this into the calculator. So I'm going to write sine 46, this time I definitely want to put parentheses, times 300, because if I don't have the parentheses, it's going to multiply that 46, which is not what I want. I want to multiply the sine of 46. So I multiply by 300, and I got that number. Yay! Okay, so that is 215.8019. Okay, and then obviously I have to divide this number on both sides. Since it's multiplying by sine, I want this thing to be alone. So I'm going to divide both sides by 219.775. Whew. Okay, now that I don't really need the diagram, maybe I'll actually zoom back in so maybe you could see a little better, just in case you can't see it. And then, now that I did that, okay, type in the calculator, so I have that perfect, the whole thing right now. Divide that by 219.775. Boom. Okay, so I get sine of alpha is equal to 0.9819. And since alpha is stuck, I have to take the inverse. So that means I get alpha, or let's actually do it how we've been doing it in class. So I'm going to say sine inverse, or inverse sine, of 0.9819 is equal to alpha. And so I'm going to type that in. So I'm going to press shift sine, and then the answer that I just had. So I got 79 degrees. And yeah, it says, oh, it doesn't say round to the nearest degree, but again, the problem gave me 46 degrees, so I'm just going to round it to the nearest whole number. So therefore, I get, again, like I said in the calculator, 79 degrees. Yay! Whew, this is a lot of work for this problem. Okay, so now you could use law of sine again, but we don't really need to because we already know this is 46 degrees, and we found that alpha here is 79 degrees. So I could figure out what beta is by just using the simple fact that three angles add up to 180. So I'm just going to say beta is equal to 180 minus 79 minus 46. And so I get, and I'm lazy, I don't want to do this, so I'm going to put it in my calculator, 180 minus 79 minus 46, and therefore I got 55 degrees. Yay! Whew, that was a lot of work. So hopefully that was helpful. That's what we get. Adios.